Welcome to the herd and thanks for listening. If you enjoy this sodcast, please like it, share it, give it a good rating, and follow, and help more people find their way into the Ruminati herd. If you have suggestions for improvements, please let me know. Howdy, everybody. Thank you for joining us this episode of the Meet Your Herdmates sodcast. Today, I'm pleased to be joined by Professor David Franzen, the Extension Soil Specialist, Soil Science Department, North Dakota State University. Dr. Franzen, thanks for joining us.
Yeah, glad to be here.
So this is going to be a little different for you and for most of the audience, but I think it's a fascinating story of at least a substantial portion of what I hope we talk about, which is I ran into you because of a talk that I saw on YouTube that you've given it several times about the history of export of phosphorus or phosphate from North Dakota. Yeah, that's not really fascinating to other people, but it is to me, and it's my program. Um, so what, in a nutshell, what does that story look like, and what's the practical kind of implication from earliest settlement to today in terms of soil fertility?
So North Dakota is definitely a prairie state. It's in the northern Great Plains, and except for around the rivers, there are no trees, there are no forests, to speak of, or at all in the state. So all prairie and all bison grazed for probably 15,000 years at least, and so an amazing topsoil depth was formed during that period of time, maybe a foot and a half or so in the western part of the state, which is historically dry, and 3 feet or more in the eastern part of the state, and very black. We're talking 6.5 to 7.5% organic matter in those feet of topsoil, just extremely rich. Wheat yields in some of the areas that receive water equivalent to what we get today, with no fertilizer, with nasty planting equipment, seed that's maybe marginally adapted that they brought over from Ukraine, and so just remarkable. So it was an amazing, and still is an amazing agricultural state. But I wish we still had that topsoil. So the whole emphasis, the whole purpose of the talk is to try to awaken people up to what they've lost, what they still have, and what they need to do in order to turn back the clock, rebuild it over the years.
So what was the period of, is it 1900, end of 1800, or is it mid 1800s that we had significant European settlement in North Dakota?
So the eastern part of the state started to be populated in maybe the early 1870s or so. There were Europeans here periodically since maybe parts of the 1700s, and of course Lewis and Clark overwintered in North Dakota in the area of Mandan, Washburn, that area, and that early 1800s, and so. But the real settlement of the prairies didn't happen until about 1880, and so from about 1880 to the end of World War I, that's when the plows came in and the state was fully cultivated as much as possible.
Okay. So we have early settlers coming in. They homesteaded. Is that accurate? That there was a land claim?
You bet. Mostly driven by the railroads. They would advertise in Europe and show pictures of pumpkins the size of people, and all kinds of vegetables that some of them we grow here and some of them we don't. But anyway, they weren't advertising then as about the same as it is now, whatever it takes. So the railroads advertise they've got people over here, and the people that were settling and pay their homestead fee help the railroads repay their debt.
And I guess there were stops along the railroad that were basically limited by the need to replenish water or fuel in the locomotives, and so that's where they needed a settlement. So
Yeah, and the railroads were given land north and south of where the railroad was going to be by the government, and then the railroad could sell it off to the settlers. And so they used that, and then later on the Homestead Act and just improving the land. Improving the land meant that you
mhm,
did something with it, which meant
yeah.
that you plowed it, which is, I suppose they would have to do that because they didn't have any other tools, but it's not really improving the land. The Indians used to call it roots wrong side up.
Yeah, the grass is wrong side up.
Yeah,
Um, so part of one of the challenges, and it may have been further east, we didn't they did not even have the right plow to deal with the sod that they were trying to break. And in fact, in I guess parts of the world that you grew up in, they built homes out of the sod. Did they do that in North Dakota as well?
yeah. The sod was very thick, and so the very first homes that were made on the prairie were all sod homes. The only people that would build a home like we would consider a home would be people that were pretty wealthy. There were a few of them that would come in and just had the money to do it, but most of the people didn't. Most of the people didn't have the money to do it. Some of the first real houses they built were built using the money they got selling the buffalo bones they picked up off the prairie.
Exactly. So I've heard descriptions of that first when they got the more improved plows for cutting through the sod. The sounded like cloth ripping as they pulled through this massive roots and plant material. And but then they had that process takes a while before you end up with something, a crop that you can then sell for money. And so, one of the things from and you just mentioned it, that collection of bones and taking them to a railhead was a source of income for many of the settlers.
It was it the North Dakota wasn't the first place to go into this kind of business. It started in the east, and as the buffalo died out there, then went west. The southern the southern herd, the remains of the southern herd in Kansas, Oklahoma, Texas, those were several years before the North Dakota time, and there were millions of pounds of bones that were shipped off on those railroads to the east usually. Some of it was fertilizer, some of it was for industrial uses. There's a picture I have in that video from a carbon black company in Detroit using it for chemicals of some kind. I have no idea why, but huge pile of bones.
Mm.
But they would get up to $20 a ton for it, and back then that was huge money. I mean, it was a lot of people that moved out here didn't have really hardly any money, and like you said, it takes a while to plow up 40 acres. Well, when you have sod that thick. By the time the people came out here, John Deere had made the steel plow, and so it wasn't near the problem it was maybe when they were plowing Ohio in the late 1700s, early 1800s. But so they certainly had that technology to do it. In fact, in the early 1900s, there were steam tractors that people would use, especially the Bonanza farms in the valley, which is another thing that the railroads use. They established these Bonanza farms that were thousands of acres apiece, and they would have pictures of maybe 20, 30 reapers in the field, 20, 30 plows in the field, all at the same time. It was a pretty spectacular thing. There's families that are here and former governors that managed Bonanza farms 100 and some years ago.
So, what Bonanza Farms? What's that name? Is there a story behind that?
Yeah, the railroad's just another marketing thing. That There's these farms and there are thousands of acres in blocks that that the railroads had, and they were managed by somebody. And then they would hire people. They would have a whole line of equipment, a whole line of reapers, a whole line of plows and discs and seeders and everything that they needed. Uh, but they were huge operations, some of them pretty close to what normal people would farm today. But back then, it was just astounding. Most farmers were thought that 160 acres was a huge, huge thing to farm, and these were like 160 acres, just huge things. And so it just caught people's imagination and made people want to move out here and farm that land too, because the yields they were getting with this newly plowed soil were astounding, way higher than they were in the east.
So the railroads were maintaining ownership of that land and
Yeah, at least
hiring people.
initially. Yeah,
Yeah.
initially, um, and then as time went on, that they broke them up, and some of the people that managed them managed to keep quite a large block of that land as well.
So a lot of how many acres is in a section?
So a section is 640 acres, and a homestead would be 160 acres, so it'd be a quarter of that. And so, farmers here, our farms are very huge compared to some parts of the world, thousands of acres. And so people talk about farming 10 quarters or 40 quarters or that kind of thing. Each quarter is 160 acres of land.
Mm-hmm. What is the nutrient composition? So that bone loss represents a transfer of nutrients out of that zone ecosystem somewhere else. And bone is going to be made of calcium and phosphorus, a little bit of protein if it's real fresh, so nitrogen, but most of this wasn't real fresh that they were picking up.
Yeah, you were exporting mostly phosphate when it's going east, and so I figured that with all the bones that were shipped out of here, although the records burn up 100 years ago when one of the railroad stations burned up in Minneapolis or someplace close to that, Northern Pacific. So the records were lost, but just given the amount of bones that are recorded on the southern herd, the northern herd was at least that much. And so I figured that we sent out enough phosphate to fertilize our farms for a couple years anyway with the phosphate that was shipped out of here. So it was kind of interesting. It's not a huge amount of thing, but what the buffalo bones did in my talk, you alluded to my talk a little bit before, but I wanted to catch people's attention, and so I started talking about the buffalo bones because it's something that certainly the younger farmers may have never heard of, and the older farmers, they kind of remember their fathers or grandparents talking about, but didn't really grasp really what it was like because they were born after that. So I wanted to give them a flavor of that. And then once I told them that, once we shipped the phosphate off the bones, that the biggest phosphate export was yet to come.
Mm-hmm. Exactly.
In the form of soil blowing away with wind erosion.
Yeah. So I shared with you my experience, my education on my last visit to North Dakota, that there's a term that I learned. And again, one of the things from your presentation, and I don't know why I made this assumption, but I always thought of Dust Bowl as being, southeastern Colorado and that portion of the country. And surely it was bad there. And your presentation made me aware of it was very bad in North Dakota as well.
It was. I don't think we had the photographers up here that they did down south. Maybe because there were more urban areas in the southern plains, perhaps because they were developed a little bit sooner than what we were up here, or maybe it's just because it was so dang depressing. Nobody wanted to take a picture of it. Really, some of the really good pictures we have is around 1934-ish, when the USDA had sent a photographer up into North Dakota and South Dakota, and there's some pictures from Williston and some around Bismarck and from that. But it's remarkable how few pictures really exist of North Dakota. Northern South Dakota, I have one myself, but that I bought in some weird way. But there are more of the big staggering pictures of the dust storms coming in from South Dakota than they are in North Dakota. But they certainly happened in North Dakota because the farmers that are in their late 80s, early 90s or so, they remember them.
So the mindset of farming, I remember people saying that the plains was at least at one point described as the Great American Desert because there were no trees. And yet it's this fantastically productive ecozone. Just doesn't have trees, but the people coming to it were used to seeing trees. And so they brought their knowledge and technology with them and tried to use it in this new zone. This problem of wind erosion didn't take from the 1880s until 1930 to show up. It started right away.
It did. It's important. It's important to realize that looking back, it's easy to see all the soil that everyone lost and think that these people were stupid. What in the world were they doing? But they were really only doing what they were taught, what they knew. They came from pretty sheltered areas. A lot of people in this area came from Northern Europe, Scandinavia, Norway, a lot of them, Germans from Ukraine a little bit later on, and a lot of them from the eastern part of the United States, and so the way you prepared land to seed was to first plow it, and then you disc 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 it, and you have to place the soil in the consistency of flour almost, because the seeders that were used to seed the wheat crop, which is wheat's a big deal here, it still is, weren't heavy. They didn't have a lot of steel on them. And they couldn't really exert a lot of pressure onto the soil, and they were either pulled by horses, a lot of them, and then later the seam tractors, but horses almost, they're really small tractors. So it had to be beaten up like that. And where these people came from, that wasn't a problem, because a stiff wind is 10 mile an hour, and that hardly moves any soil at all. But when people moved out here, they would write back to family back wherever it was, and almost to a letter they would comment how the wind blows all the time, and 20, 30, 40 mile an hour, 50s, it's not uncommon to have gusts 60, 70 mile an hour sometimes. In the springtime, during planting season, is one of those times when the soil is the most bare and you get the highest winds. So there was a for example, I came across online a brochure from a red clover seed selling company about 30 miles north of Fargo, and they grew red clover on about 1,500 acres of land, which is incredible, really. But they would talk about once the land was plowed and ready for seed, the wind would blow and the ditches would just immediately be filled with black, and that's all they did was they just kind of remarked on it, because I think they thought that land would last forever because it's so black, so deep. Mm-hmm. But this is 20 years before the 1930s. Mm-hmm. And then around 1929 here in North Dakota, a little bit earlier than what it was in Texas, it really started to dry out. And then people prepared the land just like they usually do. The crop failed. The land had all year to blow. And of course, it didn't blow every day. But I had one old farmer when I got to a point in a presentation, he just stood up in the back of the room and he just started talking about his experiences northwest of Grand Forks as a kid, that these things, these winds would come up just out of nowhere, and they would huddle in their house. They'd push newspapers, cloth, whatever they could into every cranny they could, and still they couldn't hardly see across the room, as it was just so black even inside the house. And then it would maybe last for a couple days. And the first thing they'd do when they went out was try to find the animals, because the wind had drifted over the fences, and they'd climb over the fences, and some of them died from dust ammonia. And the government had a program where they paid $10 for a horse or a cow or something like that, and you'd bring them in, and the government would shoot them because they really weren't worth anything. But if you kept them, they were just going to die. The lungs are just filled up with dirt.
And people too. I mean,
yeah, there was a lot of dust pneumonia, and a huge number of people went away from the state. The stories of the Okies are legendary, and books written about them and everything. But we have the same thing here. We have an area southwest of Fargo that's called the Cheyenne National Grasslands now. It's several thousand acres, and it's just you can tell they're dunes. They're dunes out there, and I know somebody that grew up in a town that just bordered it on the west side, and he said that when he was a kid, his dad would take him around the grasslands and say, Johnson's farmed over here, Olson's farmed over here, somebody else farmed over here. Every quarter section in that national grasslands before the 30s was farmed, and farmed very successfully. But as soon as those winds hit, stripped it all away, and nothing was there except sand that wasn't good for anything, but hopefully some grass to take on and throw some cows out there.
And that fine material that left represented a significant, as you said, it was more than this shipment of bones represented a nutrient loss to the region.
Oh yeah. I figured that from the time that the plows hit until today, we've lost the equivalent of about 200 years of phosphate application at today's present rates. An acre of topsoil 6 inches thick contains around a ton of phosphate, P2O5 we call it. And most of our state lost anywhere from a foot to 2 feet of soil during that period of time, during this 130-year period, something like that. It's huge amounts of 100 times more than we shipped out of here with the buffalo bones.
And I think it was you, and I think it may not have been in your presentation, but the comment about going back to locations that were used for soil mapping.
Yeah, my colleague, David Hopkins, he's a soil scientist and a really good pedologist, person that characterizes soils. And he used to do it in conjunction with the National Resource Conservation Service, the NRCS. They're the ones that officially do it. But there was a period of time about 25 years ago, 30 years ago, where they were about the time that they dammed up the Missouri and made Lake Sakakawea here in the state, and there was some idea that they would irrigate land in the state with that water, and that's politically it's dead right now, but at the time it spurred a lot of soil survey work. Anyway, so Dave Hopkins is a really good soil survey person, and so he went out to places that had been mapped by the NRCS in the 1960s. And so when they mapped it, they call it characterized. So you get, this is this depth of topsoil, it goes down 6 inches, it changes color, it changes something else. So soil is laid out in what pedologists term horizons, because when you characterize a soil, you're in a pit, you're in a hole, and so the soil changes on these horizontal levels. And so, the kind of like the horizons, you got this horizon, that horizon, so you get these layering effects. So he went out and went to several of these sites to see what's happened in the last 50 years. And all of the sites, except the one that was in permanent pasture, had lost topsoil during that 50 years. Every one. The one that was the worst was Western Grand Forks, and when it was first characterized, the depth from the surface of the soil to the subsoil, where subsoil is where the plants and the chemistry haven't really changed anything from when that sediment was first laid down. But they found that between that time that they had lost 14 inches of topsoil, and the farmer that was farming the land had no idea that they'd lost any at all. And I characterize it. I think what happens with farmers, and unless they're really shown, is that when they look in the back window of the tractor as they're leaving the field, it still looks as black to them as it did the year before. But it's not. But it still looks black to them because they don't have a reference. They don't know what it used to look like.
All right.
But we have soil surveys back into the early 1900s in the state. Not every county has a soil survey that goes back that far, but several do. And it talks about it. It mentions, it categorizes what the soils look like back then, and it looks like a dream compared to what we have right now, because they're talking about soils that have 2 feet thick with 6.5% organic matter, and you go out to those soils today, and there's maybe 6 inches of 2.5%. Topsoil is all gone. All you're doing is you're really farming the subsoil of 1900.
I'm speaking with David Franzen. Dr. Franzen's professor, extension soil specialist, soil science department, North Dakota State University. I remember someone saying that top horizon in some of these worst cases is essentially gone, and it's like this new sort of mixture horizon of the A and the B. The tillage equipment reaches down, so it still looks a little dark. And again, people have to be shown. It's not that people are wantonly destroying things. It's not that these people are stupid. It's we haven't realized the issues. I think you or someone there in Bismarck taught me about the little rocks on pillars in the fields.
Oh yeah, they're. You see them mostly out west, because in the east, a lot of those have been mined to use during the flood years. But it's really common to see the rock piles sitting on little pillars where the soil around them is washed or blown away, and the rocks were placed there 80 years ago on the original soil, and they're standing up there on a pillar.
Yeah,
like a butte that's.
Back in New England, you build a wall with but these fields are a little bigger than what they had in New England, and so they had to get them somewhere, and they just put them in piles and then farmed around them, and now we have this difference in height.
Oh yeah.
And one last observation from that trip, and that was a new term I had learned. So hopefully we're not talking about things as bad as they were in the 30s, although that's a pretty low bar to get over. I mean, that was horrendous. Well, we're still seeing wind erosion, and in some cases water erosion as well in these tillage cropping systems.
Well, we do. I had occasion last year to sit next to a long-term no-tiller from the southwest part of the state, and I always thought that their incentive to go no-till out there was the wind, and I think mostly it is. but he shocked me when he said that they weren't the first in their neighborhood to go no-till, but they were just about ready to plant, and they had this thunderstorm came in, dump about 5-6 inches of water on, and they had these huge gullies that were like 8 feet deep or something like that. And he said that was the day that they all decided they were going to go no-till. Mm-hmm. So the water can be a problem because we get most of our rain in those thunderstorm events, but the wind is our perennial killer. We had big dust storms this year in the eastern part of the state. I heard from a soil conservation person about 80 miles southwest of Fargo, and the field west of this rest area along the highway had blown, and the county had to come in and they took out 25 truckloads of dirt from the rest area to get it operational again in one 24-hour storm. Wow. And so it's still happening in places in the valley. It's still largely conventional till, and when the wind blows like it has this spring, a lot of soil moves.
And so the phosphorus is, I understand there's a little bit of controversy, but it's essentially a limited resource. There's some finite point where we run out.
Yeah, one of the problems with phosphate in the United States is that it's concentrated in the areas where the animals are in the east, and the phosphate is depleted from the feed grain area in the central part of the state. So having to get moved around. I mean, there's enough around to go on, but the resources in the United States, for example, are limited by where they are. In Florida, they're where the people want to retire, and so there's huge limitations on how much can be mined, and there's a question about whether it should be mined. There's a lot of environmental push and shove, and that private land, public land, that whole battle, and then as it has it in the western part of the U.S., the phosphate resources are just outside of Yellowstone Park. So, I don't know if God has a sense of humor or he's just being nasty with us. But, we have some of our resources in Retirement Central, and we have others in the most pristine area in the whole country. So that's weird. Morocco has huge reserve. China has some. Russia has some. There's some around the world, but it's not cheap. Even if you don't think about it, it's just not cheap. But to lose it from your field and not being able to raise your field levels up because it blows away every year, that's just not good. One of the interesting things is that usually the first no-tillers on the block, the first no-tillers in a region, their phosphate levels increase over time because their neighbor's topsoil blows over into them. If you're the last no-tiller on the block, then you just kind of lost it. I had a grower this spring tell me that this is after one of the dust storms, and he's been no-till for 40 years, so he doesn't worry about it. But he said his neighbors west of us, the land came up for sale a couple of years ago, and he didn't bid on it. And some other neighbors were friends. I said, why in the world didn't you bid on that land? He says, well, I'm farming his best topsoil. Why would I bid on the rest?
Oh, wow. Wow. Okay, so then the next step in the chain is, even if we didn't have wind erosion or water erosion, we're still harvesting crop and shipping it. And so that represents a nutrient loss in that crop that goes somewhere.
That's true.
And so sometimes in the forage side of things, we try to talk to people about the value of hay based on its nutrient content. It would be interesting if we thought about other commodities in the same way. Maybe that doesn't get us anywhere. But the thing that came up in a previous phone call was, if we're feeding monogastrics or similar simple stomach animals like poultry or swine or human beings, and we're feeding them grains, most of that phosphorus in the grain is phytate, which we don't utilize. So now that represents no value to us at all and a loss to the agricultural system that produced it. And we haven't gotten good at closing that loop yet. But then you mentioned sort of another alternative or an answer to that as low phytate feed grains.
Yeah, so there is such a thing, and people have known about the phytate problem for gosh a couple decades at least, and so I know that there's low phytate grain around. Um, I don't know if it's in common use. Maybe its development is maybe too expensive for a lot of people to use, but I know it's on the pork producers' radar. Pretty sure.
Because one of you mentioned the ecological problems, and it's when phosphorus gets into surface waters that we have problems.
Yeah, it's almost never a groundwater problem, but the eutrophication and the problems with the red algae and the cyanobacteria, all of that in that eutrophication zone, that's just a big problem. So trying to keep it out of the waterway, it's tough in this area because a lot of those lake beds have some of this dust blown around. I mean, the bottom of the lake isn't 1880 bottom of the lake. It's 1880 bottom of the lake plus the topsoil that came off of all kinds of acres to the windward side of it. So a lot of the old topsoil is in the lakes, and some of this is dredged out from time to time, but not a lot. It's mostly behind dams where that happens. But if you're we have a lot of potholes in the state where the glacier dead ice ended, and so we're on the migratory route. Lots and lots of migratory birds, all kinds. I don't even know the names of them all. Some you hunt, and some they're just pretty, but they're all on that route, and they all use that lake area. But those lakes, those little ponds. I don't know how you would get rid of the phosphate in them because of the topsoil that's in the bottom of them.
Hmm. So where you didn't grow up in North Dakota, did you?
I didn't. I grew up outside of Chicago. I had an uncle to farm. Of course, we all had an uncle to farm back then in the 50s. So that's no endorsement, but my dad was one generation out from Sweden, and his father was a carpenter, and Dad worked for the railroad after World War II, and my other grandfather worked at a steel mill around Chicago. So I kind of came from a steel railroad family. And when I went to University of Illinois, I decided I wanted to be a chemist because I wanted to be a chemical oceanographer, which is about as far away from central Illinois as you can get. But anyway, it had an appeal. So anyway, I went into chemistry, and then after I was in it for just a short period of time, I just couldn't imagine myself in a lab coat running around all day in a lab. So I started looking for something else, and I took a course that included soil in it. And when I got down to the pit, I saw chemistry and biology and physics and math and everything all in one place, and I thought, this is it. And so I worked my way into it, and when I was a senior, I was a student helper for a professor in soil science at Illinois, Fred Welch, and so he offered me a master's, and so I got my master's, and then I went to work at a fertilizer retailer as a agronomist, and before too long I was managing the whole thing, and retained the agronomy and became a certified crop advisor when that came up. And then it looked like my boss was going to sell. I was only 20 miles away from Champaign, and Ted Peck, who was a soil scientist at University of Illinois, was looking around for somebody to do a PhD in precision ag stuff. And So I made a deal with my boss that I would work 40 hours and go to school full time. And my wife was very long suffering for 4 years, but I did it. And after that, it was very clear he was going to sell the place. So this job came up at North Dakota State, and I was fortunate enough to get it. Been here ever since.
That's a remarkable part of the country, and I look forward to spending more time when things kind of shift back to or forward, whichever way you want to look at it. But I'm wondering, so I graduated mid 80s, joined faculty, Oregon State, left there early 90s, came back into agriculture right around 2011. Few things have changed.
Oh
my
yeah.
joke, and it's not a joke, it's serious. I was looking at a forage seed catalog and I saw this abbreviation BMR, and I thought that BMR was like a virus. So, and I'll explain that joke to anybody that wants to know. But some things have changed over time, and one of the things people may be hearing about, and you've mentioned it, no-tilling. And that's something that requires some new technology and some new knowledge relative to where people were 50 years ago. At least that's the number I'd pick. I may not be exactly right on that.
That's
But
pretty close.
so what sorts of things did, so it's clear that the less we till the soil, the better. It's clear that the more cover we can leave, the better in terms of crop residue, but better would be arguably some living plants. But then you've got competition between those living plants and the crop you're trying to grow, so you need to manage that in some way. And the people that came to settle couldn't just take a stick and poke a hole in the ground and throw some corn seed in the ground with a fish head. That wasn't going to work. What sorts of things have you seen shift over, the time since you discovered soil science and today?
Yeah. So the whole Champaign area has been farmed since what the 1880s, roughly about the same time as up here. But it was a great Illinois swamp at one time. If you look back at the old statehood maps, it shows an area of the great Illinois swamp. And nobody lived there because the mosquitoes were awful, probably malaria. They would populate the moraines, the ridges, that the glaciers left. So Champaign, Urbana is on a moraine. Paxton's on a moraine. You could go on and on. The older towns are all on a moraine that surrounds the Great Illinois Swamp. Around the 1880s, some people would call them Germans, I guess, but it was Europe was fluctuating about that time, so they knew they were close enough to the Netherlands to know how to drain the land, and so that's exactly what they did. So the land was almost free, not quite free, but dang near close to free, like 50 cents an acre, something like that. So they sent word back to their European relatives and told them to come on over and bring the kids. And they bought these steam shovels that they put on barges, and they floated them out to the middle of these shallow lakes. And they started digging to the nearest stream. They're luckier than we are here. There are a lot more streams in Illinois than there are up here. And so they made the big ditches to drain them, and then they hired people for like $1 a day to dig tile and tile those places. Now I'm pretty sure that land is what, $8,000 an acre, something like that. Hugely productive. So it was all conventional till. Almost all was conventional till when I first started out, and so that's when I knew, and pretty sure that most of it is still conventional till. Although there's a sizable amount of strip till I know, which is a modified no till that works with corn. Strip till, I mean, no till is very hard on corn because because the soils are cooler and wetter in the springtime, and it's always a yield drag. And so the strip till, you make a little strip where you're going to plant the next year. The auto steer, the GPS controlled steering that's within half an inch accuracy makes this all possible. So it wouldn't have been possible 40 years ago. You go blind trying to plant those little strips. So, but you could do it now, and so there are some people that are doing that modified no-till in that area. There was some attempts at no-till subsidized by herbicide companies in the late 70s, early 80s or so. Some of it grasped on, but not a lot of it. When I moved up to North Dakota, it was quite the shift. In the valley itself was all conventional till, but once you got toward Bismarck or so, then things changed drastically. And I got to know the early no-till adopters, mostly out in the southwest part of the state, but really all over. They had formed a network and formed an association called the Manitoba North Dakota Zero Till Association. And the first no-tillers were a few from Manitoba, and then people in the southwest part of the state. There were a group around Beach, North Dakota, which is the last town on I-94 before you get to Montana. And they were all young farmers about the same age, and people call them the Beach Boys. And so, but I don't know if they could sing a lick, but they sure knew what to do with they decided that if they weren't going to go no-till, that there wasn't going to be any land to farm by the time their kids were grown. And so it wasn't university extension supported at that time. That there wasn't anybody in the region academic-wise to really support them. They just decided they were going to try to figure out how to do this because they didn't have a choice. And so they found out that they couldn't monoculture anymore, that weed after weed after weed was not going to work. And so they diversified their rotation. They worked out things with how long the rotation has to be, and when you go to a short season crop and when you go to a long season crop. They learned that no-till and fallow wasn't going to work, that it had to be a continuous crop. So back 40 years ago, half the land in the West River was all fallow. So only half the land was farmed every year. The other half was just bare. And so people started what they call chem fallow when glyphosate Roundup came in the 80s, but they found out that it just got too wet, and so they really needed to just crop it all the time. So that was another thing that came out of it. And then after they've been in it 4 or 5 years or so, then some select people in extension and some at the USDA Mandan Research Center by Bismarck started to get on board and started doing their own research and working out on their land and having a lot of interaction with that no-till group. So it's just grown. And so now west of the Missouri River, I bet 98% of that land is no-till. It's just continuous no-till. And north of the river and east of the river, there's less of it, but there's still a lot of it. In that area. It's just the last holdout in the state really has been the Red River Valley, but thanks largely to a colleague of mine, Abby Wick, who's been here about 7-8 years now. That's starting to turn around, and more people are putting their foot into the no-till water, where before people would say it would never work. But now there's neighborhoods everywhere where people have shown that it can work, and it's very successful, and your dirt doesn't blow, and you really can farm, and you save moisture. But if you use cover crops, you can get rid of excess without having to chisel it. It's quite remarkable to see how the soil has improved over just the span that I've been here. But it really has taken a turn for the better.
So you've mentioned a figure of around 6%. So let's just, if that's not specific, let's just use it. What would you think the maximum amount of organic matter or soil in your environment could have? Is that sort of native state at 6%, or was it higher? Or
I think in the eastern part of the state, the native was somewhere around 8% or so. That's just a guess. Um, we have people in the southeast. I have a farmer friend, a colleague. I've worked on his farm. He's been in no-till since for over 40 years, 45 years roughly, and he's built some of his soils to 7.5%. And I think that's probably plateaued, but it does remarkable things for him. Never has a crop failure, always has water, never has too much water. His nitrogen rates are 100 pounds less than the neighbors. Organic matter is twice as much as his neighbors. His phosphate levels, like I said before, are in the high range, and he doesn't fertilize any heavier than any of his neighbors do. It's cheaper to farm. You need less equipment. You need less fuel. You need really less of everything. You just have to stay on top of it and manage it and be patient when it's a little bit wetter spring.
mm-hmm.
But once you get the crop on the ground, it's amazing. There's a fairly new no-till grower south of Fargo, about 50 miles, and he farms some really, really. I mean, the soil around Fargo is almost 50% clay. He probably has some that's 55 to 60%. So you can just imagine what that's like. But and he was at the point before he went no-till where he was just having to go with a perennial grass because it was always too wet. If it wasn't too wet to seed, it was too wet to combine. It was awful to work. But once he got into the no-till and then used a cover crop all the time because the land is always wet, he's out combining, and his neighbor that maybe has better soil couldn't possibly combine. It couldn't possibly hold the combine up. But he just the soil has gathered its good aggregation underneath it. It's held together. It's not. If you put a penetrometer in the ground, you'd think you'd have a little bit of compaction, but it's really not compaction. It's just the soil particles are held together in a much more stable configuration than they are with that randomness that you get when you beat the soil to death all the time.
I was watching another of your presentations, and you were, again, something new to me. I've been out of crops for a while, and no longer making yield target recommendations for fertility or fertilizer applications, and that you had been looking at a lot of data and trying to look at the relationship. And so if you could help me understand that just a little bit better, because I think there was something really important there.
So the idea that yield and nitrogen rate or fertilizer rate of any kind is related really came out of Oklahoma State. My friend Bill Ron, professor down there at Oklahoma State, the guy that developed the green seeker down there, the active optical sensor. But anyway, just a brilliant guy. And so he found out when he was messing around with the green seeker that he couldn't get it to correlate with the yield expectation. It only mattered within the field that you were dealing with, not between fields of different yield capacity. So, and then when most of the Corn Belt states, I didn't have enough data yet to throw in with this at the time, but the Corn Belt states, led by Iowa and Illinois, went together, pooled all of their nitrogen rate data for corn. And if they just threw it all up there, it just looked like some kind of shotgun blast. But when they started not thinking about the yield potential of each of the plots, the maximum yield of each of the plots, and move to a more of a relative yield, then it made perfect sense. And so when I had my data together, what I did was I would standardize each site. So say if you're working with corn, you have one site where your maximum yield was 200 bushels. So you divide all your yields by 200, so you get everything between 0 and 1. Then you had a site that maybe more on environmental stress, and the maximum yield was 120. And you did the same thing with that. So you have values between 0 and 1. You do that with all your sites, all the 100 and some sites you have. And what you get is that the same rate, the same amount of known nitrogen that's going to take to get your maximum yield in a good yielding environment is the same that it's going to give you the maximum yield in a low yielding environment. And so that blows people's mind until you start to think about what happens under stressed conditions. So let's think about a drought. We're in a drought right now in most of the state. And so in a drought, there's a lot of things that happen. So you normally get some nitrogen from the soil as the microbes feed on the organic material and the residues and release the nitrogen and the residue. In a drought, that doesn't happen because they're dormant, because there's no moisture around to make them work. So that component goes away. You certainly don't get any losses in that environment. You don't get leaching, you don't get denitrification, gas is lost, no nitrous oxide, no N2 gas going off. That doesn't happen, so I guess that's a plus. But the other thing that happens is that the root systems in a drought tend to be smaller, and the roots don't grow to water, they grow through water to get to more water. And so if the soil is really dry, down a foot and a half, something like that, the soils aren't going to go any deeper than that. And that's usually what happens in our situation in a drought, is that the roots just don't have enough moisture down deep in order to sustain their growth to deeper depths. And then the last thing, and maybe the most important thing, is the main way that nitrogen gets to the roots is through a process we call mass flow. The ammonia goes in the soil, it gets converted to nitrate by the nitrification bacteria, and then the roots receive the nitrate from the water they're picking up. Because the nitrate is dissolved in the water, it doesn't stick to the soil at all, and so it's moving toward the root with the transpiration stream. But if the soils are dry, there is no mass to flow. And so the efficiency of any nitrogen that's in the soil, wherever it is extremely low compared to what it would be in a normal year. So it takes much more nitrogen, or any nutrient really, in a drought to make a certain yield or ton, bushels, whatever, than it would in a normal year. Now let's think about the other end of the book. Well, one more thing. All right, so we've had really wet years too. And in a wet year, you have leaching, you have denitrification, you have those huge losses. You have periods of time when the soil is saturated, and during those saturated times, there is no mineralization release of nitrogen from the soil either. Also, when you have a really wet year, those root systems definitely are very shallow because the roots don't go in the saturated soil. So again, it takes much more nitrogen per bushel, per ton, per whatever unit of yield to grow a crop than it would in a normal year. Now, 2016 in North Dakota was a perfect year. We had just enough rain, scattered out throughout. It was a beautiful year. I had check plots where we didn't add any nitrogen to beginning low nitrogen in the soil plots that we were getting 180 bushel of corn, 70 bushels of wheat with no added nitrogen at all. The amount of mineralization in a year like that is off the charts. Just, you just don't need that much. The roots can grow to their full potential because there's nothing to keep them away. There's enough moisture to stimulate their rooting down deeper, and there's no water underneath in order to shallow, so it grows to its full genetic potential, and there's enough water there to feed that mass flow for the entire season. It's a perfect thing, and it takes far, far less nitrogen per bushel or ton or yield than it does in a normal year. So those are your streams. A lot more under stress and a lot less on vanilla. And so it doesn't really matter what the yield is, about the same amount of fertilizer and amount of nutrients to make a crop in a good year is a bad year. Doesn't matter. So yield isn't part of the equation.
So then it's a question of what you get for the crop and what it costs for the fertilizer.
Yeah, so we build an economic production function, is what it's called, and so we take into account the cost of the fertilizer and the price that a farmer will get from the crop. It's a little bit more complicated than that because I've been able to have enough studies in different places where I know that, for example, east of the Missouri River, it's more moist, the yields are higher, and the response curve, which means the rate at which yield increases with the nitrogen or whatever nutrient I'm looking at, is different east of the river than it is west of the river. And so I have recommendations for the eastern part of the state and the western part of the state. And I also have different recommendations for a very odd area that's it's a kind of a triangle in shape, and it goes from Devil's Lake and then moves as a triangle up to Canada. And according to my counterpart in Canada, it also goes into Manitoba, but they don't have enough data yet to really show that. So this area, and I didn't know this going in, I just knew it because the studies that have been done in that area showed that it needed a lot less nitrogen to make a crop up there than it would in the rest of it. And so I carved it out. Well, it just so happens that area was identified back in the late 50s in a peer-reviewed journal article as the Shaley area in North Dakota. And what possessed him, I have no idea, but there was a researcher at the USDA Mandan research station that took the shale out of soil samples and ran a nitrogen mineralization study on it and found that there's a high amount of mineralizable ammonia within the shale. And so that's why that area needs less nitrogen, because the soil itself is a slow release fertilizer. So amazing. So anyway, I call it the Langdon area, but it's in our maps. And then in corn, we grow quite a bit in the eastern part of the state, and there's some very high clay soil, so they're susceptible to denitrification because they're easily saturated. And so we handle these differently than we do more medium textured loamy soil, so loam soil. So the response curves are very different when the two of them. So I divided it up. And then the last thing that I do on my nitrogen recommendations that nobody else does, and I think someday they will, but they haven't yet, is we have lower nitrogen rates for no-till, continuous no-till, long-term no-till, 6 years or more no-till than conventional till. And I got this idea from those farmers that I was talking about before. So my coldest day in North Dakota was the second day of the last day of the Manitoba North Dakota Zero Till Conference up at Minot. And I woke up in the morning and it was 45 below, no wind chill factor. I mean, it was 45 below, and I plugged my car in, and so it started, and I had to go to a meeting later in the day. But I remember because of that. But then the evening before, I also remember because the long-term no-till people had invited me up for a little get-together in one of the upper rooms, and so they were glad to see me because that position had been open for a couple of years, and they were glad to see somebody in it. But they also said in the next breath that they didn't pay any attention to North Dakota State University recommendations anymore, and I asked them why. And they said, well, after they've been in no-till for a period of time, they found that they could shave their nitrogen rates back. And they've shaved them back so much that it didn't resemble our recommendations at all. And so they don't even pay any attention to them. So I said, fine. But then, 15 years later? 15 years later, I'd accumulated well over 100 site years of wheat data. And I remember the conversation, and I noted which ones were long-term no-till and which ones aren't. And so I divided them. And they were right that it took about 50 pounds less land to grow the same yield crop and really higher protein than conventional till. And so when I did the corn work and the sunflower work, I made sure that I had long-term no-till sites and conventional sites in the same neighborhood, and the same thing on each of those. So there's lower recommendations when you have long-term no-till than conventional till.
And what's a pound of nitrogen these days?
Around 50 cents a pound of N.
Is that
So
purchased or applied?
That's that's just purchased,
Yeah.
and then you got to get it in the ground. So
Yeah.
so yeah, it's like $25 an acre. Here's $25 an acre for your long-term no-till
A year.
a year.
Yeah. And before I close, this issue of soil depletion is obviously not confined to North Dakota or North America. And arguably, one could imagine it being worse in other parts of the world. Is that something you'd agree with?
Yeah, it is. I had a group of farmers from Kazakhstan come over about 10 years ago, and they were interested in sugar beet production. And Kazakhstan is kind of on the edge of the steppes in that area, and it's been farmed periodically for 3,000 years. So they lost their topsoil about 1,000 BC, and so they asked me what kind of nitrogen rate we were using for sugar beets, and so I told them that farmers would put on anywhere from 100 to 120 pounds of nitrogen, and they would get at that time 25 tons of beets. It's more like 35 now, and 17% protein, and sugar, which is about the same as it is today. And so they huddled together and they talked, and the interpreter said they have to put on 200 pounds of nitrogen to get that same yield and that much sugar. And I said, well, if you put on 200 pounds of nitrogen here, you'd have beets the size of pumpkins, but the sugar content only be 11%. So, but that's the difference. They have no organic matter, and they have to put on half again as much fertilizer as we do to get the same crop. If you have any kind of soil with no organic matter, you can put enough fertilizer on to get a crop probably, but it's going to be a lot more expensive to do so and a lot less profitable.
Any thoughts on no-till systems, and cover crops coming into that, but then the incorporation of livestock at some point, a grazing animal? Have you done work in that area? Or?
Yeah, other people have, and that's a great thing. One of the people I work with, I asked him what he was going to put in for cover crop, and he told me, and it had some legumes in there and some other things. They're kind of pricey. Usually, we just talk to people about radishes and cereal rye, but he had other things in there. And I said, well, how much is that going to cost you? And he said, around $25. And I said, how are you going to get that back? And he said, well, I buy some steers. I electric fence the thing off. I let them feed on it, and I quadruple my money when I take the steers out of it. And I thought, oh yeah. And the other thing is, we're not really seeing much nutrient cycling if we're just putting cereal rye and radishes in there. And I think if you put it through the cow, I'm not 100% sure on this, but I'm pretty, at least I think it's logical that the nutrient cycling capacity of those cover crops would be way better if they went through a cow first than right on the top of the soil.
Oh, Dr. Franzen, thank you so much for your time and sharing this information. If you have any questions for me, it's fair to open myself up. I've been asking you a bunch. Otherwise, I'll say thank you very much.
Well, thank you. It's been great.